As we've seen, the rail then slides across the floor. Don't know why the floor has a drop off here, but I decided to make it look like a tabletop, I guess. Anyhow, the rail slides across the floor. Let's say that it slides a distance delta S before it comes to rest. Then there's some frictional resistance, and we've seen some reasons why that frictional resistance is expected to be constant, regardless of the speed, assuming it's the same type of floor all the way across and no significant obstacles. The frictional resistance should remain about the same. Friction's a complicated thing. It doesn't remain exactly the same, but as long as we're sliding and not bouncing along, it remains very nearly the same. In order to continue sliding, we have to overcome the force of friction. Okay, so that the rail itself has to exert a force equal to the force of friction, but in the opposite direction. So it has to exert a force F to overcome friction. So the big F, which stands for the force exerted by the rail, equals a little f of friction. Then we see that the work it does against friction is the work equals force times the displacement. And that's just the frictional force times the displacement. Now let's stop and think about what we have. We put energy into the system by stretching a rubber band. We released the rubber band and it propelled the rail forward. When we doubled the stretch of the rubber band, the rail went about 4 times as far. Now why should that happen? Well, let's think about it. If we double the stretch, we double the average force and we double the distance through which we stretch the rubber band, right? If we double the force and double the distance, then we're going to have 4 times, quadruple, the energy or the work. We have 4 times the force times distance if we double the stretch from this to this. 4 times the force times distance. So we're going to get 4 times the force times distance here. Now the big point is that the force isn't changing. The force of friction is whatever it is. So if we're going to have 4 times the energy here and expend 4 times the energy and do 4 times the work, since we got 4 times the energy out of the rubber band, it has to go someplace, and it goes into this. With the same force, we're going to go 4 times the distance in order to get 4 times the work.